Hi guys, so we're now question 181 to 4, because all these questions are similar. So what we're going to do is we are going to look at mixing yield. In exam mode, I'm going to be sort of tackling it like that, so you can see how I would do this quickly under exam conditions. So what am I saying here? Well, I'm saying here that you guys are making a kitchen, right? We expect you to use, if you like, it doesn't really matter, 15 hours. That's the key point. It's all about output, right? Yield is about output. So because it's about output, the truth is I'm not too interested in the actual breakdown of the inputs. It's still standardized. You'll see what I mean, because I'm only interested in output. And you've used 18 hours. That's the bottom line. The bottom line is you've used 18 hours. I really can't be too bothered about the inputs. I'm interested in the outputs. So in effect, you've used 3 hours more than you should have. Now, if I want to cost these 3 hours, well, I'm going to cost them based on the sort of our standard agreement. The agreement, right, was that you would use labor in the ratio 5 hours for skilled and 10 hours for laborers. So that's, if you like, 1 to 2. If you like, that's kind of the order here. So if I do that again in that order, 1 to 2, that's the ratio, that's the agreement. Key point is you've used 3 hours more in terms of making this table. So from that point of view, that's what I literally do. I just compare, if you like, just subtract the two. You've used more than you should have, and literally split that in the standard ratio, if you like. And so splitting that in the standard ratio of 5 to 10 and 1 to 2, the skilled labor is at £30. This is adverse, by the way. You've used more than you should have. We expected you to use 15 hours in total, and you've used 18. And this is times 12. So this is, of course, 30, and this is 24. And this is, therefore, 54 adverse. So the answer is A. Yes, that's the labor yield variance. It's adverse. And that's pretty much it. Find the totals. That's all we're interested in. Find the difference and split it according to that standard ratio. We see exactly the same thing here. So what do we see here? We expect you. You've read, of course, you're reading the question before you're coming through to do this. So it says that this is what we expect. We expect you to use expectation. We expect you to use 750 grams of chemical A, and we expect you to use 350 grams of chemical B. So in effect, to make 1 kilogram of this new product, of this cosmetic, cosmetic X, we expect you therefore to use 1,100 grams. I mean, in effect, therefore, to make 10 kilograms, we therefore expect you to use 7,500 grams and 3,500 grams, right? If I'm going to be making 10 kilograms, I mean, this is for 1 kilogram, this is 10 kilograms, right? 10 kilograms. Now, what did you do? This is what you did. You did 9,500. I'm only interested in the totals, by the way. And you did 2,600, and that comes to 0, 0, 11, 1, 10, 12. So you used 12,100 instead of using, if you like, 11,000. So in effect, you used 1,100 kilograms more than we agreed. It's just that's all I'm interested in. That's what you used. So again, what do? Split this according to the ratio of our the ratio of 750 to 350. This is a standard ratio. When we do the mixed questions, you'll see where this becomes a bit more important. The ratio is 750 to 350. So that's the ratio. 750. I mean, thankfully in this case, the 750 to 350 naturally matches this, right? So we can basically, if I split this in this ratio, I will have 750 and I will have 350. Well, and I multiply this, of course, by the standard prices, and that's 0.5. This is adverse, by the way, because you have used more than you should have, right? And this is 0.5, and this is 0.8. And that takes you to 3. Let me just calculate that in my head. Well, sorry, what am I saying in my head? In my calculator, 0.5. That takes me to 375, and then 350 times 0.8 takes me to 280, and together that takes me to 655 adverse. That's adverse. You used more than you should have. 655 adverse, right? So what am I saying here? Just get the totals. Just get the totals. Whenever you see yield, get the totals in terms of volume used, and just subtract them, and then break it up in the standard combination, because we want to understand. We want to basically cost that difference, right? And that's what we need to do. Mix, though, is just a bit more interesting. I actually find mix a bit more interesting. The key issue here is that you are supposed to use, it's almost like the price variance. We don't care what you did. You went out there and you did 4 and 14. So you did 18 hours, right? The whole idea is with these 18 hours, we expected you to use that 18 hours in the mix 5 to 10, if you like, right? 1 to 2. That's what we wanted you to do. But you went along and you did something different. You did a different mix. So let's look at the mix variance. So in this mix, how should you have spent those 18 hours? Well, with 18 hours, you should have spent, well, 1 to 2 is 1 over 3. Well, 1 over 3 and 2 over 3, right? So therefore, this would be 1 over 3 times 18 is 6, and this would be 12. So you should have used 6 hours of skilled and 12 hours of labor. So what we now have here is a 2-hour variance here of favorable, because you used 4 instead of 6, and 2 hours here of adverse. So let's look at that 2 hours of favorable. That's 2 times 30, which is 60, favorable. And we have 2 times 12, which is 24, which is adverse. So therefore, we have a 36 favorable variance. 36 favorable variance. And that's what the mixed variance is. The mixed variance says take the actual hours that you did, split them up in the standard that we were expecting, compare the two across, and value that, and then put a value on that. Okay, good. So that's 36 favorable. So mixed variance is very much about the mix, comparing the standard mix with what you actually did. That's when we actually bring in the 4 and 14. So we're really interested in inputs. It's a real input variance, actually, to be honest. So here they give us a standard mix again. They tell us we want you to mix things up in this ratio, 7 to 2 to 1. What did you go ahead and do? So you went in 12,000 kilograms. You went and you did this. You did 8,000, 3,000, and 1,000, making 12,000. We're like, no problem. That's the 12,000. What should you have done? That's 7 2 to 1. So that's 70%, right? So 70% of 12,000, 0.7 times 12,000 is 8,400. We're saying you should have used 8,400. So here we have 400 favorable because you didn't. You used 400 less. You should have used it's 12,000, 2,400. So this is A, B, C. 2,400. You should have used 2,400. You used 3,000, so that's 600 adverse, and the balance, therefore, 8,400 is minus 12,000 is 1,200. You should have used 1,200. You used 1,000, so that's 200 favorable. Just change my pen color, which means, therefore, that when we now value this, the standard prices of chemical A, for example, is 4, this is 3, and this is 2. This is 1,600 favorable. This is 1,800 adverse, and this is 400 favorable. And when we do that together, we now have 1,600 favorable plus 400 favorable minus 1,800 adverse, which gives us 200 favorable in the end. So we have a 200 pound favorable variance. So the key point is take the actual amount of kilograms that went in, and let's just look at the mix. You decided to change the mix. I don't know. Think of it like I've used this in class. Think of it like a cocktail. You've changed the mix of the cocktail, and we just want to understand whether you've saved or you've spent. You just want to see what savings you've made. Basically, typically the mix variance is very much about saving because you're trying to substitute a more expensive component for a cheaper one to see if you can save money. But then typically the problem becomes with the yield, with the output. All right, finally. Oh yes, I said I was going to end there for that. That's for that questions, and for those set of questions, sorry. And then we will start with question 185, new topic somewhat, and we'll carry on from there. Okay, great stuff. See you in the next video.